Hello.
Hello. I have homework
That's
from
great. From
so
school.
if yeah, it's logarithms.
All right.
So I
So, mhm.
I just want a little more clarification with it because I feel like I have it, but I need a little more.
Know
So
that.
I'll send the homework to you
Okay.
again.
Yep.
1 second. Hmm. Oh yeah. Okay. Okay. I just sent it in the chat.
Mhm. All right. So we're having like solving of the logarithm. So this is all about log, right?
Yeah. Log and then what's it called? Rational functions. And like I just need help with the factoring for it. It has me a little confused.
No problem at all. We'll be understanding this thing much clearly. So first of all, to start here, I'll be going through some little basics, and that is related with, when you're having big numbers, when you're having a simple number that's in multiplication with itself continuously. For example, 10, let's take a simple number 10, and you're multiplying it with like 3 times, 10 times 10 times 10, then you can write it as 10 cubed, right?
Yes.
And you can have any other number also, like 2, and you're writing 2 times 2 times 2 times 2, so it'll be like 2 to the 4th power, right? Very simple. Now this thing is actually the exponential form. I mean to say, sorry, this is the what do you say, the power exponent form. You're having an exponent on some power, right, on some number, and this exponent is going to tell you that how many times you're multiplying this base number, right?
Yes.
All right, now let's take the thing in a different manner. If what does this log mean in terms of this exponent, because this is exactly opposite to the exponent. So if I'm having log, okay, so 10 to the 3 is how much? 10 to the power 3 is how much?
1,000.
1000. So if I'm having log 1000, okay, if I'm having log 1000, but the base is 10, like the small number here is 10, it's telling me what number I have to raise to this base to get 1000. That is what is
Oh
log about,
yes.
right?
Yeah, I practiced that on Khan Academy, so it made more sense.
Okay, amazing.
Yeah.
So
So then it'd be equal to 3.
correct. That's amazing. So log 1000 to the base 10 is 3, because we have to take the power 3 to 10, so we'll get 1000. Now if I'm having log 64 to the base 2, what does
That
this
would
mean?
it would mean that what do I have to raise to the base of 2 to get 64?
Correct. What I had to raise to 2 to get 64. So like we can 2 times 2 times 2 times 2 is 16, and then again, can you check it on the calculator? How much will be this number? 2 to the which power will be 64?
2 to the... Oh, 1 second. Sorry.
No problem.
I think it's
You can go on multiplying 2 continuously. On
oh,
the
okay.
calculator, you can go on multiplying 2, 2, 2, 2, and so on. Which calculator are you having?
This one.
Is it the scientific one?
Yes.
Okay. So you might be having maybe some power, because I'm not able to see it clearly. Like which number you have to raise. Or okay, no problem. You can just check it out.
6. 2 to the 6th power.
To the 6th power. Okay, I'll be doing it
Mm-hmm.
on my calculator. 2 raised to the 6 is 64. You're right. You're absolutely right.
Okay.
But there's another way of, understanding this. 2 to the 6 is 64. I can take log 64 to the base 2, and that is 6. It's exactly the same thing, but the representation is different. So the 6 will be the answer, right?
Yes.
So this thing is exactly same as this black thing, like 2 to the 6 is 64. Am I right?
Yes. Mm-hmm.
So there's a relationship between these two things. Okay, now till now it's about, we're having different bases, 2, 10, and whatever. But what about when you're not given any base? And that time we don't write log, we write ln, ln. That means at that time, the base is always and always a number that is called Euler's constant. That's E. For example, ln 27 to the base E. So whenever you're having the base as E, that means it is a special log. It's called ln. And E is having a value. It's an irrational number. And that value is, let's try to check it on the calculator, 2.718 and so on. E value in physics. No, not this E. Euler's constant, EULERS. Right, see here, 2.718281838, so on and so on and so on. It's an irrational number, and we take the first three numbers, like 2.718, as that number. So that is the natural log. It's called the natural log, right? So it's having a special, place in physics. That's why we are interested in this base. That is 2.718.
Okay.
Now that's why the question 2 is giving you ln of x. That means the base is
8.
right. The base is E. And sometimes it's giving you log of 8 to the base 8. That means the base is 8. As simple as that, right?
Mm-hmm.
Okay, before going again to these questions, we'll be doing 3 rules of those logarithms. 1, 2, 3. When you're having addition of, log m times n, any two numbers and their multiplication, then you can write them as log of m plus log of n. Base is all same in all those three. Log of m times n is log m plus log n. In the same way, log of m divided by n is log m minus log n, and log of m raised to the power n is n times log m. So these are the 3 things which you have to use for solving all types of logarithmic questions. So log of any two numbers multiplication is actually log of m plus log of n, like log of 2 times 3.
Oh, like the exponent rules?
A type of, yeah, correct. Same type, Log of 2 times 3 is log 2 plus log 3. In exponents, you're having the same basis. 2 to the 3 times 2 to the 4. You're having 2 to the 3 plus 4, right?
Yes.
In the same way, you're having log of 2 times 3 is log 2 plus log 3. Or else you can have log of 5 over 2 will be log 5 minus log 2, right? And log
Yes.
of 2 to the 10 will be 10 log of 2. Bases will be same, we don't discuss the bases here. We can have the same base like 10 or 2 or E or whatever you take.
Okay.
Right? So these are the 3 rules which you need to apply. Log of m times n is log m plus log n. Log of m divided by n is log m minus log n. And log of m raised to the power n is n times log m. Okay, till now?
Yes.
One more thing which I want to tell you is a little different. Maybe all the students don't know this thing, but if you know it, then that'll be much better because you can have some edge over other students. And that is, if you're having, for example, you're having log of 10 to the base 2, but you want the answer in the base of 3. Okay, you want the answer in the base of 3. So how can you convert this thing into base 3? So what you'll be doing is you'll be writing this thing here. You want to base 3, so you'll be writing base 3 in the numerator and base 3 in the denominator. And you're having here 10 and 2, you'll be writing 10 and 2. That's it. Log 10 to the base 2 is log 10 to the base 3 divided by log 2 to the base 3. You know?
Oh, okay.
Any two numbers. Yeah.
So if I just wanted to put it to that base, then that's what I do. I just do log 3.
Yes.
Okay.
If whatever the base you want. For example, the question is log of 10,000 to the base 4, but you want the base 10. So what will be?
Oh.
You know?
Okay. Yeah.
Log of 10,000 to the base 4, but you want to the base 10. So it'll be doing?
So then you'd have log 10 for both of them.
Log to the base 10, log to the base 10, and then the numbers are?
For 10,000 or 1,000.
Yeah, 10,000 and 4. Correct. Log of 10,000 to the base 10 divided by log of 4 to the base 10. That will be exactly the same as log of 10,000 to the base 4.
Okay.
So this is called, a base changing formula.
Okay. So will the question be formatted like if you want base, like Bob wants base 4, so how can we? Okay.
Exactly. So that's perfectly right. So if you want some other base and you're having some other base, then you can use the base changing formula. That's it.
Okay.
So whatever the base you need, you'll be putting that in the numerator as well as denominator, and putting those numbers which you're already having in that question.
All right.
All right. So 4 things we have discussed here, 3 rules and 1 base changing formula. And now we'll be trying to solve the questions using these 4 tools, 4 guns, for us.
Yeah.
So in question number 1, try to always figure out, is there any fraction which is having the same denominator so that you can have addition and subtraction, simpler?
We can do the butterfly method, the cross.
You can do the butterfly method, but there's much better method also. I mean to say, there's 2x here and 2x here. Can't we take them together, like adding 5 over 2x to both sides?
Oh yes.
So that you'll be having 3x over x plus 1 equals 3 over 2x plus 5 over 2x. Is that right?
Yes.
And then you'll be having you'll be having 2x is the same as the denominator in the right side, so we'll be putting 2x there, and 3 plus 5 is 8 over 2x is equal to 3x over x plus 1.
Yes. And then
what it'll be doing?
Oh, trying to get x on one side.
Yeah, but they are in multiplication and division, so what will be doing?
Oh, simplifying them or factoring
Yeah,
them?
how can we? Do you know cross multiplication?
Yes. Oh yeah, I can do cross multiplication.
We can do that. So we can do the cross multiplication. So 3x times 2x will be
6x
squared.
Oh, x squared, yes.
And then 8 times x plus 1 will be
8x plus 8.
Right. And this will be a quadratic formula. You can take the other things on one side, negative 8x, negative 8 equals 0. Am I right?
Further? Yeah.
So we need to calculate the value of x, right?
Yes.
And this is a quadratic formula, quadratic equation. So for calculating the value of x, you can use the quadratic formula or a calculator, or
Complete the square?
factoring or completing the square. Exactly. Right.
All right.
So the best way I could suggest, if you're having the the availability of a calculator in your school for these questions, then you can directly go to the calculator. See, how can I solve it on the calculator in very simple manner? I'm having apps button here. Maybe you might also be having, I'm not sure.
I do not have that button.
But you might be having some quadratic equation or mode or something, where you can solve for the quadratic formula. You might be having, it's in the Casio also, some other simpler scientific calculators, they are having this option of using the the quadratic equation in the calculator. So see here, I'm going for apps and then PLY SMLT2, and then click any number, and then you're having polynomial root finder. So that is what I want. I'm having the highest power is 2. So next. Now I'm having numbers A, B, and C. A is 6, B is -8, and C is -8, right?
Yes.
A is 6, B is -8, and C is -8. So I'll be trying to solve it. So I'm getting the values as 2 and -2/3. So I got the values as the x is 2, -2/3. But this is the I can show it
Can you show me how
again.
to come the other way, the factoring work?
Yeah, definitely. I can do it by using the quadratic formula also. I know that x equals -b plus minus square root of
4ac.
b square minus 4ac divided
4ac
by
2a.
right. So x is equal to, how much is b?
B is 8, -8.
So negative times negative will be positive 8, right? Plus and minus square root of b squared
64
minus 4 times a times c
4 times 6 is
is
24
times -8.
24 times -192.
And negative times negative, won't that be positive?
Yes.
Divided by 2 times a. How much is that? 12, right?
Yes.
So then
Plus
we need to simplify it. So x equals 8 plus or minus square root of 64 plus 192.
21.3.
21.3. Oh, really?
Yes.
Okay, 21.3 divided by 12. But how can we get
divided by 12? I'm sorry.
Oh.
It's 80. My bad.
No, what about square root of 64 plus 192? How much was that only? Like 64 plus 192. Yep.
Oh, never mind. 13.8.
192
for the square root
plus 64 equals 256. Did you got 256?
Yes, I did.
So square root of 256, right? Square root of 256. That's 16 only.
Oh, I'm sorry. I messed something up. I have a
That's what I was thinking, like why I got the decimal. I was like, okay, so it's 16. So I'll be writing 16 here. So 16, 8 plus or minus 16 divided by 12, right?
Yes.
So x will be 8 plus 16 over 12, or 8 minus 16 over 12.
So 24 divided by 12 is 2.
And
2, that one's 2. 8 divided by 12, which is 2/3.
8 minus 16 is -8 divided by 12, right? And 4 times 2, 4 times 3. So it'll be 2.
So -2/3.
Negative, which we got on the calculator. That's it. So remember the quadratic formula. You'll be able to get any value. Sometimes you don't have, some clear, cooler numbers in terms of x. You might be having some maybe irrational numbers. At that time, the quadratic formula is better, Otherwise, if you'll do the factoring, you'll not be able to factor it out. You might be confused at that time. So always try to prefer quadratic formula if the question is not telling you that you have to do it only by factoring or completing the squares.
Okay, 1 second. Let me write the rest of the notes down. So do you always want to make sure you square root before you divide it?
Yes, you have to. Because
Okay.
square root is actually raised to the power 1/2, and PEMDAS tells you after parenthesis you have to do exponents.
Exponents. Okay, thank you.
That's why.
Exponent, well. So would you say, would you prefer that I do quadratic formula before
Yes,
factors?
because I preferred myself.
Okay.
So
It seems easier.
yeah, it seems to be just picking the numbers and just putting it in the formula and getting the answer. That's it. And if you're using the calculator, then it becomes more easier. But if
Okay.
you're not having the calculator, then the things become a little difficult. And you can even, if you get the answers on the calculator, you can directly write the answer. You just can trick it out. You can just make a trick that you can write 6x squared minus 8x minus 8. You can write directly as x minus 2 times, x minus 2, times x plus 2 over 3. So you have factored it out.
Oh.
See what I did? I know that x is 2. So when I'll be subtracting 2 to both sides, I'll be getting x minus 2 as one factor. Think about it. So, and another one, I know that x is negative 2 over 3. So when I'll be adding 2 over 3 to both sides, I'll be getting x plus 2 over 3 as another factor. So I got the two factors.
Oh, okay.
So we have done the factoring, but by tricking the things.
All right.
So we have not thought about like what really the numbers could be. We have got the answers from the calculator, and then we use the factoring thing. So we can do anything, whatever you like, whatever you feel feasible. And if you're, if you're good in using the formula, then definitely I'll prefer the formula.
The formula seems better because like I've had trouble factoring, like it's been confusing.
Obviously, there will be. You have to think about that. Like, which numbers should I multiply so that I will get this thing? Which number should I add so that I will get this thing? Yeah, correct. That's why. And those numbers should be some natural numbers. If they are like, some fractions, 5 over 4, 9 over 6, how can you get them? That becomes more difficult. That's why it becomes always easier for using the, by using the quadratic formula, you can get the answers quicker.
Yes.
So we got the x as 2 and negative 2 over 3. Right?
Yes.
Okay, now let's move to the next one. Okay, what was the first rule of logarithms, which I told you?
Oh, it was log m times n equals log m plus log n.
Right. And if the question is log m plus log n, then can't you write log m times n?
Yes.
So what is question number 2 here?
Oh, okay, same thing. So you can write log log ln x.
Ln or log, it's,
Ln.
yeah, ln, and then you're having two things. This is m and this is n.
Okay, so you'd multiply those together.
Right, because they're in addition. So it's like log m plus log n in the question. Then you can write log of m times n, right? So ln of m, instead of m, I'm having x. And instead of n, I'm having?
Instead, you're having the x plus 2 squared.
X plus 2 only, right? Log m plus log n is log m times n. So log m plus log n, log m plus log n is log of m times n. So m is x and n is x plus 2. Are you getting it? Is there any confusion here?
Yes, I get it.
So I'll be writing directly log of m times n, log of x times x plus 2.
Mhm.
And that is equal to 3.
Equal to 3.
Right. Now, we are having ln of x times x plus 2 equals 3. So, like, did you do this in the school? Like, how we will get, the answer after this?
One second. Let me go back to my notes. What we did was
Mm-hmm.
I think we multiplied, but
Mm-hmm. X squared plus 2x.
yeah,
Yeah,
I'm pretty sure that's what we did.
okay. Because I just want to make sure that we are following the same procedure. As I told you, log of any number, like 1000 to the base 10 equals 3 means
Means what do we have to raise 10 to the power of what in order to get 1,000?
correct. So we can write, this can be written as 10 to the power 3 equals 1000, right?
Mm-hmm.
Now think about the same thing here. Log of something having the base as e, as I told you, the ln is having the base e. Did the school teacher told you about e?
Yes, he did.
Okay, so ln of something to the base e equals 3. So how can I convert this exactly in, like, as I converted here? Think about it. Log of some number to the base 10 equals 3. That can be written as that base raised to the power 3 equals this.
I think maybe x to the power of 2 equals.
But x is what? X is as if you're having 1000. X times x plus 2 is as if you're having 1000, right?
Oh, so it'd be 2 to the power of x equals 3?
Why 2? Is it which power, like which is the base here in this side?
10.
10. What is that 10? Isn't that base of the log?
Yes.
What is the base here?
Oh, ln.
Exactly, e, right? So what can you write here? Think about it, because I just want you to think about it more.
You could do ln.
Forget about, like, you just say that log of some number. Okay, I'll be
Log of
writing,
some.
yeah, log of some number x times x plus 2 can be written as x squared plus 2x. Log of some number to the base e equals 3. Like here, log of some number to the base 10 equals 3. We wrote that equal to that base raised to the power 3, which is on the right side, equals here, this thing. I can write this in a more general form so that I can be more clear here. Log of, or you can say ln of m equals n, and the base is here e.
Okay. Thank you. So then it'd be ln of e.
Ln is now clear. Like, you don't have to write ln when you're using the base. You're using the, you're using this thing here, e to the base n equals m. That is equivalent to this.
Oh, okay. So
I'll be
would
doing it
it
again.
be,
Yeah.
so would it be e
Uh-huh.
2x, no,
To the base, which is on the right side. So to the
e to
power,
the
which is
base
e
of
2, which is on the right side.
e to the power of 2x.
Mm-hmm. 2x is as if you're having m, m is x squared plus 2x.
Oh,
Okay, and E is this E, and N is this 3.
Oh, okay. So
Okay, ln of m to the base E equals n. Now we can compare. E is E, m is x squared plus 2x, and n is 3. So what can be written here?
so you would do E
Mm-hmm.
to the base of 3 equals x squared plus 2x.
Right.
Okay.
Or x squared plus 2x equals e to the base 3.
All right.
Or you can write x squared plus 2x minus e to the base 3 equals 0.
Oh, okay.
Is it?
Yes.
And then you can use the quadratic formula, or you can use the calculator to get the value of x. But I want to know whether you tried this thing as I try, like whether you did the same thing in the school or not.
We did the same thing, but
You are not clear,
yeah.
and you're still not clear much. I mean to say, 100%.
No.
Yeah, that's that. We will be doing this again.
Okay.
So, okay, I'll be taking an example so that will be more clear here. Ln of 2 plus ln of 4 equals, let's take it as, x. So which rule you'll apply here?
You'll apply. Oh, you'll do log.
Mm-hmm.
Oh, you do log 2 times log 4.
2 times 4 only, The first rule
Oh yeah.
was ln of m times n is equal to ln of m plus ln of n, right?
What's the difference between the log and the ln?
Just the base. Log is having any base except e. Ln is telling you that I'm having the base as e. That's it. Nothing else. This is the natural logarithms, natural log.
Okay.
That's why it's called ln. And this log is having any base, 2, 10, 20, whatever that is, that'll be defined in the question. But when you don't have any base, when you're having only ln written, that means it's telling you that I'm having the base as e.
Okay.
So ln of 2 plus ln of 4 can be written as?
It can be written as log 2 times 4.
Right, that's 8. Ln 8 or log 8 is equal to x, and the base is e. Now, how can I convert that into exponential form?
Oh, okay. So e.
Yeah.
So it'd be
E to the?
e to the power of x equals 8.
Right. Simple. Now, what you can remember in short is you go counterclockwise, starting from the base. E to the power of this equals this.
Oh, okay.
Okay. So E starting from the base to the power of this equals this. Now I'll be doing it for one more question. Ln of 2x squared plus 3 having the base e equals 4. So what I'll write?
So e to the power of 4 equals 2x plus 2 squared plus 3.
Correct.
Okay,
So
thank you.
counterclockwise. Right, so we'll be doing the same thing here. Ln of x plus ln of x plus 2. First of all, we'll be converting that into?
The x squared plus 2x.
Yeah, because you're having log of m plus log of n equals log of m times n. So that's why it'll be log of x times x plus 2, and that'll be x squared plus 2x, correct?
Mm-hmm.
And that's having a base e, and it's equal to 3. Now, what should I write here?
So it will be, so e to the power of 3 equals x squared plus 2x.
Done. So
Thank
x
you.
squared plus 2x equals e to the power 3. Or e to the power 3 equals x squared plus 2x. Or x squared plus 2x minus e to the power 3 equals 0.
So that's it?
No,
Oh, no.
now we can use the
Okay.
quadratic formula.
Okay, yes.
We can use the quadratic formula, and I can quickly do it on the calculator first. And then we'll be using the quadratic formula. So going to the apps, and then PLYSMLT2, and then polynomial root finder. Next. Okay, A, B, and C. How much is A?
A is 1,
And B
is 2,
and C
is 1.
is negative e to the power 3, whatever that
Oh.
is. Yeah, because that's a constant. E is 2.718. That's a constant, right? It's not a variable.
So what would you write?
I'm having e here, you see, very small e.
Oh.
Or else here also I'm having e. So I can use e to the power 3.
Oh, yeah, I have that on mine too. Okay.
Okay, so, but I'll be, I have to write negative e to the power 3. So negative, and then e, where it is, it's here. And negative e to the power 3, right?
Oh, yeah.
So that's it. Okay, it's like this much. It's having actually this value. Then solve. So I got the two values, negative 5.59 and 3.59.
Could you show me how to solve that with the quadratic formula?
Yes, definitely.
Okay, thank you. Because I don't have it on my calculator.
All right, we're having 2 minutes for this. We'll be logging in again for after this. So you have, okay, so let's get started. So quadratic formula is x equals negative b plus minus square root of b squared minus 4ac divided by 2a, right?
Mm-hmm.
Since I told you e is having the value of 2.718, right?
Yes. Oh, yeah. I have that in my notes.
So e to the power 3 is?
Oh, okay. So 2.718 to the power of 3 is, I got 20.0792.
20.079. Okay, fine. Done. So x equals negative b. What are we writing here?
So you'll write x equals plus or minus negative 2
Plus or minus?
plus or minus 4. I'm sorry, 4
And then?
with so if 4 times 1
Times negative
20.
20.079.
Yes.
So how much will that be? 4 times negative 20.079. That'll become positive here.
Yes.
So how much is 4 times 20.079?
4 times
20.079.
0.79 is 80.3.
Okay, so how much is 80.3 plus 4? Yeah, good.
80.
Good. So how much is 80.3 plus 4?
80.3 plus 4 is 84.3.
And then divided by, and you're having divided by 2a, that's 2 times 1, that's 2. Now negative 2 plus minus square root of 84.3 divided by 2, right? Now what are we solving first here? Square root of 84.3, isn't it?
Yes.
How much is that?